So you can, let me share. So we're going to look to one of the most useful and important part as well in the terms of process scheduling. Previously, we saw the first one, which is quite simple and easy to use in the terms of, in the terms of scheduling the processes, in CPU, okay, based on the task which they have. So we saw first come, first serve, and the first come, first serve, we saw that that is known as a non-preemptive. We saw it as a non-preemptive. And non-preemptive means what? No priority. So you don't have a priority. Means what? First come, first serve. Means the time given means the burst time given should be there until you complete your process. Even if other processes are live at earliest, if you hold a burst time, you need to complete it. This one which you see here, shortest first or shortest job next, it carries both. It can be preemptive. It can also be not preemptive. So the first leg which I'm going to look in is going to be in between. For me, I consider it to be in between. In between the sense, it may first have some criteria which you need to follow, which can be considered as a priority. And the second, it can follow no priority. Okay? So let me come to this one. So what does it mean, shortest job first? This shortest job first, this shortest job first, which we have here, visible, right? So we say shortest job first, or SJF, or sometimes we call shortest job next. This is known as a scheduling algorithm. This is a scheduling algorithm which execute the processes based on the burst time. Okay, we want to execute the processes based on what? Burst time. The previous one we did what? Arrival time. So this one we're going to follow what? Burst time. Burst time come first, be served. Or if you have a shortest burst time, you're going to do job first. You understand? I remember this time, I remember when I said this, many times I used to start from the easiest and then it goes to the toughest, right? Means things which requires a short time, you do fast, and then those things which needs higher time, you can do at the last. And I have seen some people who start by eating like the dessert, the soft food, and then they go to the Heavy food at the last. Right. Spicy one. So here we look to the bust time. Bust time means what? A time a process is given to complete. Yeah, to do the job. Right, to do the job. So here we look, that's gonna be called bust time. There are certain things that you have to understand here when we say, I'm sorry, here I'm gonna put BT just to have the good shot of the word which you write here. So this you can name it as a first point to understand. Okay. The second point to understand here. The second point which I want you to understand, which you also find, we say that bust time, which is BT, is equivalent, or yes, if I say is equivalent, or you may say is equal to, say, execution time. Okay, so you will find it. Yes, please. According, yes, yes. Arrival time will work because we shall see. That's why I said this is a mixed. It's a priority versus, preemptive versus, preemptive plus not preemptive. Because in the case which you are mentioning, we shall see during the exercise here. If a job comes fast, you need to look for the first incident. Then you proceed with the bus time. Okay? For the rest of, for example, process one came at, let's say, at 0 time. Means 0 time means it is already in a ready state. So you start looking to that one, check its bus time, and then you're going to compare to the rest of the bus time. So you start from that one. So we look in the exercise here. Good. So, so one more point to understand in this bus time, shortest job fast. It is also, this one, it's, shortest job fast is also known as disk scheduling algorithm. Why this? Because in operating system, there are different layers. So every layer, there are the block of memories, right? The block of memories. So to pass through this block of memories, if you want to access this memory, you need to send requests. So these requests are going to be answered based on what? Based on the one who sent first, or those who have a short time. So that's why it's also known as a disk scheduling algorithm. Others we saw was about CPU here. It's a quite, interesting to know that they're related to the scheduling. To the disk. Okay, to the disk. So this now the work of operating system here. Here we say that operating system. In operating system which you have such as Windows, Linux, or OS, this operating system manage timetable of all requests, okay, of all requests in proper manner. So remember that this, if you want to access any of the disk here, you want to send a request. So the request here, I can put here that request needs to be sent in order to access memory. So imagine you have, for example, I mentioned here example process. Let's say this is process. Let's say process 1, process 2, process 3. You can keep name them. You can keep name them here. You can go to process N. We'll send request. Okay, it's gonna send a request, and then once you send a request, what is gonna happen? Then operating system is going to manage all these requests which have been sent. I will put in this form way here for you better understand, for you to understand. Okay, so okay, here it will work out. So let me show you one of the example which you can consider, which we can take. For example, here, this is an example which I'm gonna take here. Let's say this is, let's say this is gonna be take an example, this to be processes. We take an example, these are the processes which we may have here. You can name them 1, 2, 3. Let's say this process is done with a small arrow. Let me see if I can reduce this one. No, that cannot be. Okay. Okay, take an example. This is the process. And when we have the process which are in a ready queue, or these processes are in new state, this process can come here. Let's say this process are coming in this way. You consider this to be, let's say this is gonna be the way we write the process, right? Process 1, 2, 3. This is, let's say, this is the table management, right? This is a table management of the processes. So here you can have a process 1. Let me write here. You can have a process 1. Sorry. You can have here P1, P2. So you keep writing them here. They are there. So when they are here, a process can come from here. Let's say a process can come from there. What color of the pen? A process can come from there. And this process is going to go to the running state. You can put here like running state here. This can be like running state. Sorry. So you can write, it can come here as a running state. So it moves from the, from the ready queue. Where is my mouse? This is gonna be running state. And this process, which you see here from the running state, allow me to change this one. This is very weird.
So there are the pointing down arrow on the shape box that is used.
This one?
In the shape, you go for
here.
On the third row.
Third row.
The
Here.
first one. I mean, in that box.
This one.
Go a bit. Very close. Left.
Left. My left
Third
here.
row,
This
third
one.
row on that box.
Which one? This one. Left arrow. This.
Third row, the first one.
We have a first one, second row, third row.
Yes.
Oh, excellent. Correct. Thank you. I was struggling. So that one can be removed. So it comes from here, and it came to the this ready state, and then from ready state they come here to the running state. So from the running state to come from here, just here is the important point. You know, this is important point here. For where's my mouse? Here is important point. I'm going right here. Here, a process right here. Process with fast. A process with fast request will be moved to running state. Okay, with the running state. So this is the thing. So it will remove to the running state. So a process with this one is going to come from here, the already queue. They came to the process ready state. Now, if you have a fast request, we're going to move here based on the burst time given. Okay, based on the burst time given. So let's say this is the one part here. The second part here, look here. Here we are in the running state, right? We are in the running state. Show me again the arrow down. Yeah, here it is. And again here. Here there can be two things. Here you can say if a process completed here, you can have a process which can come from here, and the process is going to be terminated. Okay? Here you can have what? A terminated process. So down here you can have a process can be terminated, or the process can terminate, can end in this state here, right? In this state. But before a process terminates here, I'm sorry, before this process terminates here, we can also, a process can be sent to the release, to the waiting. I'll explain to you, I'll expand here. Let me bring once again here. This one. Sorry. Where is the move? Where's my move?
Then use that one to crop and then you can move.
Oh, I crop and move.
Yes.
Very complicated. Okay, so here we have this one. This can be what? This can be waiting, right? So it can be in waiting. I mentioned, and I'm gonna say something about this one. So we can have this in waiting. So here, keeping in mind that a process, it can either be terminated or it can be sent where? It can be sent to this one. Where is side arrow? Okay. 1 minute. Just to make it more.
Just crop and delete.
So this process is gonna come from here. All right. So we have the process there. Then the process in, let's say, a new state, and then it comes to the ready state here. The one with the shortest pass time is gonna come in here. running state, and once we finish, it can be terminated. And let's say we have a process number 3. Look here. If you have a process number 3, let's take an example. We have a process number 3 here. Let's say P3 is here. P3 is coming here. And this P3, it has the bus time to be 3. Let's say 3. And the bus time for process 2, the bus time for process 2, which we have here, this was, let's say this was 5. 5, this was the P1, this was the P2, which is equal to 5 bus time, Pt. And P1, let's say P1 was 0. I mean, let's say P1 was, P1 was 4, right? P1 was 4. Remember, it came as a fast, right? But with the bus time which is equal to 4, it will be the running state. Now, when the P2 comes, bus time is equal to 5, it continues, right? When the P3 comes, with the bus time is equal to 3, P1 is going to be removed from running state to the waiting state. You understand? Now here, in the waiting state, what are we going to have here? Here we're going to have P1, right? P1. When it goes here to P1, we are going to have, this is going to be 4 minus 1. That's how I will explain to you. Let's say, take an example. P1 will be here. In the running state, we are going to have what? P3, right? P3 will come here. P3 will come here. Will come here. Because the bus time is 3. And the bus time of P1 is 4. Is removed, preempted. Priority is going to be given to that one. You understand? So this is the shortest time. So shortest job fast. So we look to the execution mode. Right? We look to the execution mode. So they keep moving like that way. So these are the part which you can understand, right? So we come from the process here, and then we come to the ready state here. Where is it? Yes, here. This part here, we come here, and then we send everything down there. So here, process can be terminated. A process will be terminated if the bus time is complete. Right? If the bus time is complete, process is terminated. Right? So this is known as what? This is known as a shortest job fast. Okay, shortest job fast. So yeah. So shortest job fast. All right, so let's see. Okay. So I think this one, if you want, I will send to you. So this is shortest job fast. So no problem. So okay. So this is the work which you can think about, right? So this is a shortest job fast, the things which you can understand about this shortest job fast. So I want to give you an example here, and then you can see how you can make on Gantt chart. Okay? I'm going to give you an example so you can imagine what you can do to that one. Oh, this one, writing is not good. Okay, so I'm gonna give you one process there. Not sure if this is share. Mr. Nut, I cannot see my mouth. I see. So let me try to share that one. So what is it? Yeah. Okay, so here, let me give you a simple example of this shortest job first here. Take an example of the following. Take this following. Let's say we have the following table here. I'm gonna give only two. We have process ID, and also here we have the burst time. And the first process ID which you have here, let's say P1. Sorry, that's too far. Let's say the first process ID here. Let's say the P1 which you have here, you are given 17. And the P2, you are given 6. P3, you are given 3. And P4, you are given 2. So you are told to, to find, let's say, to create a completion time from this. Can you find the completion time for these processes? Find the completion time. Right? You can calculate the completion time, right? We are considering a bus time. You can make a Gantt chart from this by using the bus time. In a case, arrival time has not been given. Remember this shortest, right? Yeah. So can you create it? Can you make it? Arrival, can you create the completion time? I will come and check. Completion time. I think this is gonna come. This okay. Whatever you do, I will accept it, but it's very tricky. It's not so much time. Sir. 28, correct. 28 is correct. 28 is correct. So here, there's those, like Mr. Nat, he gave initial time as a 0. But if you look to the initial time here, start by 2, and then you calculate completion time. Great. Because it's not given there, right? Yeah, but he assumed, but you get 28. You managed to get 28. So now we'll look the important point here, which we want to discuss about this one. Now here we are going to give you. Now I'm going to give you two. I'm going to give you one more column here. Let me add one more column here. And this column which I add here, I'm going to add this column. And this column I'm going to, let me give a fresh one. So we're going to apply the rules, which are going to be, which you're going to use here. Now I'm going to give you the second one. We have the second following processes along with the arrival time. It's going to be ID, arrival time, and burst time. So this is PID, this is arrival time, this is burst time. So for the first process one, the arrival time, let it be 2. For process 2, let arrival time be 1. And process 3, let arrival time be 0. And the burst time for the first one is going to be 1. And this is going to be 3. This is going to be 2. Okay? 2. Now, you are told to calculate, let's say you want to find turnaround time. You want to find what? Turnaround time, data, or waiting time, and also average corresponding to them. And their average. Before I forget, before I forget this one, your assignment will be to compare the average time of shortest time and the first come, first serve. Okay, you can check both. You can do in the same case and then find which one has much waiting time. Remember, this one we look what? The burst time. The other one we look what?
Using same this.
Yeah, we use either this or the previous one. Let me show you here the hidden trick here. Before you check, I'm going to mention here, before you look to the burst time, you need to look the process which came early. Look the process which came what? Early. Okay? Now it's going to be P3. Right? Once you find the P3, you write it. Okay? You write it. So once you write this P3, you write it along with its burst time. The rest of the process, you consider the burst time. The one already which is P3, it's already where? In a waiting. After this, the rest of the process, you have to look to the what? Burst time.
So you want us to take that process which comes first at arrival time.
Yes.
Consider the arrival time first.
Yes.
And the rest what comes after that.
They're gonna be burst time.
We're gonna consider the
Burst time. This one which I'm mentioning is not preemptive. In the preemptive would be other case. Just here, just to make you understand. For no preemptive, we look that as a first rule.
So this one, so we start with 0 plus P3 0. We don't consider it first time.
Which one?
For P3, sir, when you make the chart,
Yes.
we put like 0, 1, 3, right?
No, 0 to 2.
0 to 2. Okay.
Yes. and then you follow the one which came with the burst time. And you get it? And you calculate the sum. I will show you, right? So for those who may not understand here, let's look here. You follow here. So here, what I'm gonna do here, before you start, I mentioned once again, before you start looking the burst time, you need to look the one which came earlier, which is P3. So to calculate the turnaround time, you need to have what? CT, right? So to find the CT, what do you need to do? Gantt chart. Okay, so here I go with my Gantt chart. This is Gantt chart. So I look the one which came process, which came early, which came what? Which came early. So the arrival time is the P3. So it starts from 0, and here we're gonna have what? P3. P3 was given how much time? 2. Right? Now, right from here, we look to the burst time. Remember, we are looking shortest job past in what? In no preemptive. Okay? In no preemptive. So now we come here. We look which one has the burst time, earliest burst time. Which one? P1, right? We put here P1. P1 and the completion time for P1 is what? It's gonna be 3. It was given 1, but plus the one which you have here is gonna be 3. Correct? It's going to be 3. Right? It's gonna be 3. Now the last one is which? Which one? P2. And the completion time is gonna be 6. To confirm, the completion time should be equal to the total burst time. What I'm saying, burst time means foundation burst time should be equal to the, the last completion time. Is it equal? Summation of what? Burst time should be equal to the completion time of the last process. Right? 6. This is to confirm. If they are not equal, then may not. No. Yes, miscalculate. Okay, so you need to do that. So this is what? Shortest job first in preemptive. Once you get this one, you can do the rest. Yes, please. Now what is it? TAT?
TAT is
1 point?
So what you want to ask is
Yeah, it's written there. TAT, WT.
Sir, what?
This is not average working capital.
Was not the after videos.
No, we look at the past time. Yes. All right, so the bell has rung. We'll meet in the next class. But Priyash, I want to check that. I'm so interested to see. So if you have any question, please you let me know. If there's no question, then we'll meet in the next class. Pardon me?